All right, welcome back. Here with us is the team behind Detonicon. Can you talk about the game and introduce yourselves?
So my name is Hung.
My name is Anthony.
And our game project called Detonicon, and the purpose of our project is to study the effect of latency compensation in computer games. So a bit about Detonicon. Detonicon is basically a game serve as a test bed for our theory, where latency compensation will improve gameplay experience as well as gameplay performance. The game itself is a survival-based strategical game where players will try to attack other players using bomb, and they can kick the bomb, they can move around, they can earn power-ups in order to strengthen themselves, and be the last one standing is basically the tagline of our game.
I love the fact that they have T-shirts.
So these T-shirts plug the game engine called Dragonfly, which our professor Mark Claypool created, and that's where the game Detonicon is created in.
Okay,
Very cool.
Yep.
So you had mentioned that this is actually a test bed for latency tests or latency evaluations, but the game itself is pretty fun. But you only built that as a layer just for this entire, experiment underneath. Can you talk a little bit about what you were trying to get at with this latency test? Like, what was the hypothesis here?
So the hypothesis is that latency compensation actually works and helps players improve their performance as well as their experience during gameplay. Right. So first we create the game Detonicon. It's network, and network affects gameplay. So like lag would make your performance go down. Right.
Yep.
And then we test the game at various latencies with latency latency compensation turned on and turned off. To see whether latency compensation actually helps players improve performance as well as like how the game feels. Like
by latency compensation, do you mean interpolation in between different pings, or?
We're using player prediction latency compensation. So basically, the client gets to move before getting an OK message back from the server.
But they'll display it and rubber band it if it's wrong.
Right. Yes.
Okay.
Cool.
I got to ask tech question. How do you cause false latency these days?
Right, so we're using a queue. So messages sent to the server are just captured on the client and held in a queue, and then popped off and processed by the client once the allotted latency time has passed.
Okay, so it's just a manual timer, but you're relying on artificial latency.
Right. Yes.
What was the most interesting thing that you learned here? Because this technology. Or the need to reduce latency has been around for a long time. What's new?
So we discovered that latency compensation actually does improve player performance. Like for example, survivability. The players playing Detonicon improved on average 9.47%. And
that's not insignificant.
And then players also thought the game was way less difficult. So they thought the game was 27.2% less difficult while playing with latency compensation.
Wow. How big was your sample set?
Just 19 players.
Oh, okay.
What was your process for evaluating this stuff?
So basically, apart from doing the player study, we also play with test with bots. So basically, we just let our computer on and let the bot play the game itself, trying to kill each other, and we get the data. And actually, surprisingly, our data coincide with what we expect from the player study as well.
Interesting.
Yeah.
That's interesting. Did you guys make actual the bot behavior? Did the bots have perfect information? Was it random strategy behind that, or was there actually knowledge that was being fed to these bots based off of what they could see of the environment at each point?
So basically, when we develop the bot, we try to make sure that the bot is similar to human as much as possible. That means that bot only knows what human player knows. They can remember other players' power of the bomb, for example. But these kind of remembering stuff and characteristic are determined by our own customized value assigned to each bot in order to give different bots different personalities. So that's why in the game when there's a 3 or 4 bots, none of the bots will be the same.
Okay. Yeah, which I experienced when I was playtesting.
Yeah, and basically the way that the bot decide the action is using a decision tree, and it will be based on the surrounding itself, as well as there are 2 personalized value. One of them is called brave value, where it determines the bot aggressiveness, whereas the other value is called the smart value, determining the bot awareness, like how well do they remember all the players' ball power.
Okay, and so you just tested this with a bunch of random inputs on these bots, basically? And
Yeah. So because our main purpose is to test the latency compensation, so we use an assign number of brave value and smart value just to keep our text like a bit like consistent.
Was there a paper that was coinciding with this that you guys wrote? Or were you guys working with just this, for, like the project you guys were building here, and the goal is to test latency compensation, were you digesting your results and presenting them anywhere, or is this just here at this public event, I guess you'd say?
So it's just for our MQP. Basically, it's for our graduation project.
Okay.
And it's basically everything from making the games to testing the latency compensation technique is on our own. We basically just do like a lot of research on what is there available right now, and we just try to implement what we learned from that and try to show our result through data and stuff. And yeah, that's about it.
So, as Joe mentioned, you must be using a bunch of extrapolation and then rubber banding. That strikes me, and I'm not a multiplayer network programmer by any means, as something that's most useful on the moment-to-moment core, the physical. But you also mentioned that there are metagame elements like powers and the ability to gain new powers and so forth. What considerations need to be made for the non-physical, if you will? To put it another way, I get a power, but according to this guy who's been, 1.5 seconds behind me, I don't have it yet. Is there anything like, because you are physically proximate to this power, you're probably going to get it, and therefore, even though I'm lagging, you probably have it?
So
Hasn't been validated yet?
Yeah.
So basically, because like the way that the bot interpret the other players, they can choose to predict correctly the amount of power, or they can just play the safe bet, basically just try to stay away as much as possible until they get more data. So basically it's like they don't necessarily need to get the correct amount of the power from other player. They can just predict the maximum amount, and they can just get away from it.
Okay. So, all right, you said that it gets, the player performance improves by a certain value. I think you said about 9%. Is there a point where the latency becomes so severe that the player actually starts doing worse because what they perceive to be true is no longer true according to the server? Like, is there a point where after, like a tenth of a second it's fine, 2/10 of a second it's fine, 2 seconds is terrible? Like, did you test the far reaches of that?
So maximum amount of latency we tested is 1,280 milliseconds between the server and client round trip time.
Okay.
And the data so far has always had players with latency compensation performing better than players without latency compensation.
Makes sense. We got 30 seconds left. What do we want to ask them? Toughest question. What next?
So future work would have to be like developing a different type of game, so like 3D, FPS, MOBA, those types of games.
Try and confirm your results?
Right, because the Detonicon is a kind of niche genre. It's 2D, maze-based, so it might, the findings we find in this game might not correlate to like other types of games with latency compensation.
That'd be a scientific way to go.
Yep.
Thank you so much.
Yeah, thanks.
Thank you.
Thank you.